Positive whole numbers can be made by evaluating the expression 3a plus 5b for a and b whole numbers.
I don't understand the question. I really don't understand. Can you explain that to me?
It's any whole number that can be formed by adding any multiple of 3 and any multiple of 5.
So any smallest number that can fit into A,
I don't understand.
and the smallest number that can fit into B, that
Well,
will make
explain
it
to 5 different ways.
like 1. Like, so you could do like 3, like 10 to negative 2, B.
Yep.
And then we have times of times 5 to 3.
As long as we put A
Like, it was
it can be just A plus themselves. But or it can be negative because if you add two negatives, it can be positive.
So A and B can be negative as long as the outcome.
So I
Oh wait,
think
these are even numbers.
so like, put negative 2 in there.
I think so.
Except for 0. You can get any number except for 0.
So prove get 71. Prove it, get 71.
Alright.
That is easy.
A plus 5
That's exactly what she's gonna say though.
Okay, so all we have to do is bring.
It has to be a whole number, so it's not true if you're saying it can't be like, it's not any. Because it's, yeah, but why can't we get that?
I think we could get 71.
I mean,
But it can't be done.
no.
Yeah, that's the problem.
Yeah, no, you could because 21 and 50. If you had 7 and 10, if A is 7 and B is 10, 3 times 7 is 21 plus 50 equals 71.
94. Let me write that down.
94.
Yeah.
3, 24. So if A equals 8 and B equals 70 divided by 5.
Oh my god, 13.
14? Yeah, so if A is 8 and B is 14.
So does it really work for everything?
Because it has to be whole number. We're just using whole numbers. Whole
Row or
numbers
one,
always get
are you thinking of a column row?
Let's just
addition, so it's not like question.
yeah, 68 you could do 3 equals into 48 16 times. So if A is 16, 68 minus 48, B is 4.
Good math.
So you could literally do it for any number. It's gonna work as long as you can find a multiple of 3 that will leave like a certain number left over. Like, you know what I mean? It's like if you had 64 and you wanted to get that, you just take out like 24, so you'd have 24 and 40.
So basically, if we were to do steps, we could like pick a number, pick half this whole number.
Yeah.
Like do it off.
And we can be sure that this way we actually get all
get
the
10.
numbers.
10?
Why is that?
You're gonna have to explain it.
Like, would that happen if I would have given you 2 and 4? Or is there something special that it only happens for 3 and 5? Like, there's something that I think that we're not really pointing at yet, why that's happening.
Table. It's my table.
Okay, great.
No, it's just
And Will, do you also want to write something up?
Mine's not done yet though.
Well, just so far, to give the groups an idea what you're thinking about.
Words and math.
Why do you start with the 3 column with -2 and the 5 column with -1? Doesn't matter what it's for. We see how it says like.
Yeah, I don't know.
It doesn't. It's not like.
I just chose random
I'm
values.
sure it made it too.
I probably could have made it consistent. I just chose random values.
More questions? So can someone explain, someone from not from this table, explain in their own words how they got to the table? Huh?
And looked at each value, each multiple of 5 and 3, and added them together.
which gave them a specific value for each listing too.
They have a very systematic way to look at those. Okay, and then what did you find?
So somebody else noticed that there was the pattern, like the diagonals went like 1, 3, 5, 7, 9. So it was odd numbers in this diagonal, and then 4, 6, 8, 10, 12, 14 in that diagonal, and it alternates. Like here's an odd diagonal, even diagonal, odd diagonal, even diagonal, and between all the diagonals and all the values that we came up with, we realized that it equaled, that with this equation we could find all positive numbers. And we realized that this pattern was so because 6 is an even number, -3 is an odd number, so it alternates even, odd, even, odd, even, odd, even, odd, and this alternates odd, even, odd, even, odd, even, odd. And when you add up an odd and an even, it makes an odd number, and when you add up an even and an even, it makes an even number. So when you add up like an even and then here, like an odd, it comes up with an odd number. So to get this value, we did even, odd, and there we get it. And then like odd, even. And so then that's how the diagonals worked, is because they're all, like this diagonal is made of all odd and even numbers added together. And then the even diagonals are made of all even and even numbers added together. And that works because each of these, because 3 and 5 are special in that their multiples always alternate between odd and even.
I have a beautiful, beautiful argument, beautiful proof. How are you guys doing with that? Does it make sense? Questions? Questions for Laurie or her table? How are you guys doing on, yes, this makes perfect sense, I kind of get it, or no, totally doesn't make sense? Can I just see a show of hands? Okay, great, thank you, Laurie. A matter of time, we'll move it forward.